Okay, let's start the 8-5 notes. First thing I'm going to do is, so in the 8-5 notes, we're going to be factoring things that look like trinomials, just trinomials, x squared plus bx plus c, that have no number out front right here. But first, I'm going to review some of the other factoring techniques that we've done before. Okay, so in the first one, the first factoring technique that we learned was taking out a GCF. So if you look at 3x squared minus 9x, you notice that 3 and x are shared by both. So you take the 3x out front. But don't forget to write in parentheses what the 3x gets distributed to so that it is the same exact expression as this. It's just a factored expression. Okay, so same thing right here. We did problems like this before. GCFs are numbers and potentially variables, and it could be more than one variable. It just depends on how much they share. So if you remember, we talked about they share a 7, and then I would say, do they have an x in common? They do. Do they have an x squared in common? They do not. So the most that you can take out is an x. With the y's, we go through and say, do they share a y? They do. Do they share a y to the second? They do. Do they share a y to the third? They do. Do they share a y to the fourth? They do not. So the most that you can take out is y to the third. So then basically we just divide it out and write what's left over when we divide it out. So those are, excuse me, some greatest common factoring reviews. These two right here, we also talked about these. We did differences of squares. So if you look at x squared minus 25, since it is a difference and both of these two things are perfect squares, we break it down to basically a plus b and a minus b. So whenever it's a difference of squares, it's the square root of the first term and the square root of the second term and a positive and a negative of the same thing. So it's x plus 5 times x minus 5. Okay, so this next one is 100y to the fourth a perfect square? Yep. Is 9z squared a perfect square? Yep. Is it a difference? Yes. So then break it down to the form a plus b. Let me write that down. So in the form, if it's a squared minus b squared, that means it's a difference of squares. It always breaks down to a plus b times a minus b, something of that form. So basically just take the square root of that, take the square root of that, write a positive and a negative of the same thing. Okay, so now we did talk about these. So what happens when, maybe I'll go like this. What happens when we have something like this? So what's the GCF of 3x squared minus 48? Definitely a 3, correct? So we take out the 3, and this is what we have left over. But my question is, are we done? No, we are not. This is also a difference of squares. So leave the 3 out front, and we're going to break this down to x plus 4 and x minus 4, because when you pull it out, it goes backwards, and you need the 3 there to make it this. All right. So here's another one that I want to show you. So take out the 5 and an x. Left over would be x squared minus 4. X squared minus 4 is a difference of squares. So that also breaks down further to 5x times x plus 2 times x minus 2. Okay, so let's look at some new ones. So this is the good stuff. Okay, we talked about this briefly before we left, and I want to talk about this again. So if we have a trinomial and there is no factor out front, all we have to do, remember my favorite trinomial right here, is find factors of 12, so factors of 12 at the end, that at the same time add to 7. Okay, so I did 3 and 4. Outer and inner would make 7. 3 times 4 is 12. So this is the only way to factor this trinomial right here. Ask yourself, why did I not do x plus 6 times x plus 2? or x plus 1 times x plus 12. We also have talked about this before. Yes, 6 times 2 is 12 for that. 1 times 12 is 12 for that. But the outer and inner here make 8, not 7. The outer and inner here make 13, not 7. So neither one of these would work. So you have only one set that will always work. So from this point forward, I want you to remember that we always need to think about, so number 1, is there a GCF? Number 2, is there a difference of squares? And number 3, is it a trinomial that looks like x squared plus bx plus c right here? Okay, all we have to do is find factors of c that add to b. So I'm going to pull these up here. Hopefully you can see them. Okay. All right, so when we first start this, a lot of kids will start writing down the factors of 24. Okay, so I need to find the factors of 24, but they have to add to 11. So if you write down all the sets of factors of 24, you can see immediately that the only pair that can possibly make 11 is 3 and 8. So that's your only choice to break it down. So put x times x for x squared, put 3 and 8 for 24, and check to make sure that your outer and inner, your signs, are correct to make a positive 11. All right, let's go over here. 42, x squared minus 13x plus 42. Again, I listed all of the factors of 42 right here. Which set could possibly give me a negative 13? Negative, positive, any combination. What is the only set that can give me negative 13? Right? That would be the 6 and the 7 would both have to be negative. So let's try it. So let's do x and 6 and 7. And we've got it because outer and inner, if they're both negative, that would total up to negative 13. But on the end, when you multiply a negative times a negative, it's a positive. So we just did our first one with a different sign in it. So let's try this again. Okay, so right here, I've got x squared plus 9x minus 36. Can you think of the factors of 36 immediately? Okay, and you can list them in order, or you could just do stuff like this. 6 and 6, 9 and 4, 3 and 12. Okay, let's just see if one of those is it. All right, can any of these three give me 9? Well, yeah, this set right here, 3 and 12, could give me 9. Which one would have to be positive and which one would have to be negative? Because I need it to be a negative 36, but I also want it to be positive 9. So it would have to be, the 3 would have to be negative, the 12 would have to be positive. So then just go ahead and break it down. So here we've got, my marker. So x and x, and we've got 3 and 12. Okay, so we already said 12 would have to be positive and 3 would have to be negative in order to get 9. But negative 3 times 12 is negative 36. So we got it. Okay, so let's try example number 5. Okay, can we do it without writing down the factors? What are the factors of 8? What are the only factors of 8 that can give you 7? X and x and 8 and 1, or 1 and 8, doesn't matter what order. But you tell me, which sign would it have to be to make a negative 7? The 8 would have to be negative. The 1 would have to be positive. And if you refoil it back out, you'll go back to the original trinomial. Okay, let's try another one that has variables on both ends. Okay, so what am I looking for? I'm looking for factors of 55 that add to 6. I mean, think of the first set of factors that come to your mind with 55. 5 and 11. Can 5 and 11 somehow give you 6? Well, here we go. So put x and x. And don't forget to put y and y for the y squareds. And then outer and inner will be xy's, which is what we need. How do I get a positive 6 out of 5 and 11? So I'm going to put 5 and 11 and which one would have to be positive? The 11 would have to be positive. The 5 would have to be negative because that would make positive 6 and at the same time multiply to negative 55. Okay, so I'm going to do one more right now. And I want to see what you think. Okay, so if we have an area problem right here, and they say, hey, the area is x squared plus 7x plus 12, and you know the length, can you get the width? Well, of course you can. All you have to do is factor it. So if you know it's x plus 4, what times 4 makes 12? This is my favorite trinomial, so this one's easy, and that's why I used it. So the width would be x plus 3. Okay, we need to know to factor so that we can find these missing lengths. What if they gave us neither one? Like, what if length wasn't there? And what if width wasn't there? It wouldn't matter. You could still tell me both because all you have to do is factor it and get the two things that multiply out to x squared plus 7x plus 12. Okay, so I'm going to really quickly remind you all, this is really why we are factoring. Okay, because eventually in chapter 9, I'm going to ask you to find the zeros of this parabola, right? So to find the zeros, we are going to set it equal to 0. I think we did that in chapter 2 or 3. Finding zeros, we set it equal to 0. But the only way to get x separated is to factor it out. So we factor it out. And then in chapter 9, we're going to talk about this thing called the zero product property. And that allows us to set this part to 0 and this part equal to 0. So when I do that, I get that this one, when I subtract 3 from both sides, I get negative 3. When I subtract 4 from both sides, I get negative 4. So the solutions to this parabola are at negative 3 and negative 4. Okay? So go ahead and get started on the bookwork and let me know if you have any questions. Good luck.